Hello, everyone, and welcome back to our supplemental videos for physical science. And today we are going to discuss quarter 3, module 8 of your self learning modules in physical science. And this is all about reaction theory and chemical reaction rate. Let's start. So, chemical kinetics. This words pertains to the branch of chemistry that studies reaction rates and factors affecting rates. So, as we all know by now, we already know that um, our molecules and actually atoms down to its subatomic particles are actually moving. They are very dynamic. They are not stagnant and they do not stay in one place, most especially if they are applied with heat and different types of energy. No? So, ang ato ang mga molecules, they move a lot. Okay, now there's this one thing which we call chemical kinetics, which is branch of chemistry that studies all the reaction rates and all the factors that affect the rates or the speed, no? Kung sa ba kapaspas nag-move ang certain molecules or atoms and so on and so forth. Now, we have this what we call collision theory. Now, this theory states that the rate of a chemical reaction is directly proportional to the number of collisions between reactants. Pag maingon tag directly proportional, it means nga kung ang isa ka factor nagataas pod ang another nga factor, no? Or not really the factor, but masyag cause and effect na scenario. If magtaas ang isa, mo taas ang isa pod. Okay, so that means nga ang rate or ang kapaspason sa imuhang mga chemical reactions kay magdepende sa number of collisions between your reactants. Pag taas gani ang number of collisions, that means nga mas paspas ang rate of chemical reaction. Mo na siya ang pasabot sa collision theory. However, no, naatay mga not all reactions or not all collisions kay maka-cause og chemical reactions. Naay mga collisions nga dili siya mahitabo, no? It won't happen. A chemical reaction won't happen because only those which collide effectively will result in a chemical reaction. So unsa ba ang criteria nga makaingon ta nga ang collision kay effective, no, maka-cause siya og chemical reaction? So, nadiri sa baba, for an effective collision to happen, the following conditions should be met by the reactants. First one, they must be energetic enough to surpass the activation energy or the energy barrier. Now, I am going to explain what this activation energy and energy barrier is all about. Basta kay kasa at this point, you need to know that there should be enough energy for a certain collision, not na kailangan niya i-surpass or kailangan equal sa ato nga certain nga amount of energy para effective ang ilahang collision. Pagbangga sa imuhang duha ka molecules is mag-form ang imuhang bonds or naay mga break na bonds ug naay ma-form na another bond. So mo na siya ang kinahanglan, no? First is enough energy to surpass the activation energy or energy barrier. Second one is they must be properly oriented when they collide. So dili di ay nga pag magbangga lang imong mga molecules mo automatic makahimo ka og another substance. No, they should also be arranged or oriented properly when they collide or when the collision happens. Dapat nasa tamang posisyon ang imong mga atoms para pagbangga nila, diretso ma-break ang bonds, no? And then naay ma-form na bag-o nga bond. Okay, and now on this point, I am going to explain what this proper orientation is all about. Now, consider the reaction of two CO molecules or carbon monoxide molecules. Mo ni siya ang carbon monoxide. The gray circle indicates your carbon atom and the red circle indicates your oxygen atom, no? So you have reaction there ng naakay duha ka carbon monoxide or 2 CO molecules plus O2 nga molecule. So oxygen, and this will yield to 2 CO2 ka molecules or carbon dioxide molecules nga duha ka buok, which has an activation energy of 277 kilojoules per mole. So mo ni siya kung ginamin kaganina nga activation energy, kay nahanglan nga para ang imuhang collision mahitabo, kay nahanglan nga ang energy applied or ang energy sa collision would be equal to 277 kilojoules per mole or above that, no? Pwede niya ni i-surpass para mawala or walang mo go over sila sa fence ba, no? Mo go over sila sa imong gitawag nga energy barrier in order for the chemical reaction to take place. Now, let's go back to proper orientation. So, dapat na ay duha ka ani. This is your CO. Okay, duha daw ka buok ani, and this is your O2. Two atoms of oxygen bonded together with a double bond. Okay? So, kung nakay duha ka CO daw, nya isa ka O2 molecule, maka-form ka og 2 carbon dioxide molecules. Now, this two, no, are the structures of CO and O2. So, gray is the C, red is your O. And below are 3 possible ways the molecules can collide with one another. So, I'm going to show you that right now. These are the 3 possible positions nga mag-collide ang imuhang sa tawagan ni imuhang CO molecule o O2 molecule. Now, for letter A, as what you can see, no, ang tapad or ang nag-collide is kaning kaning isa ka O sa imong CO o kaning isa ka O sa imong O2. No? For letter B, ang nag-collide kay si C, the carbon atom in your CO molecule, and the O atom in your O2 molecule. Nga ni siya. Pwede pod ing ani naka-vertical. So, in this case, duha ang nag-interact. Ang C sa imuhang CO o ang isa ka O sa imong O2 and the O in your CO and isa ka O sa imong O2. So, magtapad na sila din ha. Nabay mabuo diha nga bond. No? So, muna siya ang pasabot sa possible nga orientations. Now, among the collisions sa A, B, and C, only B is expected to proceed in a reaction because it is the one which is properly oriented. This is based on the fact that this collision is expected to form a bond between C atom of CO and O atom of O2, which is what is seen from the structure of CO2 below. So kung atong tan-awon ang CO2 nga molecule, ana ay hang dagway. The C atom should be at the center of the 2 O2 nga, not O2, 2 O atoms. That is why, kung atong balikan ang imong orientation, ang pinaka-possible nga mahitabo ni siya, kani nga sa tawag ni arrangement sa imuhang CO2 is only letter B, right? That is why among the 3 collisions, only B will proceed into a chemical reaction. So muna ni siya ang imong final na product. This is your CO2 or carbon dioxide molecule. Because the molecules are not properly oriented in collisions A and C, they will not lead to the formation of the product, which is CO2. Okay, muna siya ang pasabot sa proper orientation. Now, let's proceed also with the explanation of activation energy. So, kinahanglan nga ang imuhang energy sa collision should be higher than the activation energy. Okay, the activation energy or the energy barrier is the energy needed to be surpassed by the reactants for a reaction to occur. When energy barrier is higher, the reaction is slower. Syempre, let's just imagine a wall. So, naakay wall na medyo tagahawak, nya tapos naakay wall nga hasta yung habuga, mas taas pa sa imuha. Okay? So you have two types of activation energy. Which one of the two walls or energy barriers ang mas dali ambakon or tungason? Syempre, katong mubo-mubo itong tagahawak. Mas dali ka maka-surpass ato. Mas dali ni mo siya malusutan compared sa katong wall nga hastang taasa. That is also why nga kung baba ang imuhang activation energy sa isa ka chemical reaction, mas paspas ang chemical reaction rate. Whereas, ang taas ang imuhang activation energy, syempre, lisod tungason, di ba? Na gani ko. Therefore, hinay ang atuang reaction. That is the reason, okay? Now, it should be noted that not all properly oriented collisions have enough energy to result in the transformation of the reactants. The kinetic energy of the reactants should be high enough to exceed the activation energy. Therefore, for CO to react with O2, katong kaganina nato na situation, the kinetic energy of the reactants should be greater than 277 kilojoules per mole. Moto ako ang gi-mention kaganina, no? So, kung masking ing ato ang orientation, for example, naka-align og tarong ang imuhang CO o ang imong O2, no? Naka-align sila. Kaso, baba ang kinetic energy sa imuhang reaction. Dili gihapon ma-form si CO2 because you need to surpass no 277 kilojoules per mole nga activation energy. Okay? Let's proceed now with determining what is a chemical reaction. Ganyan na pa ko sige gawya unsa man ning chemical reaction. So a chemical reaction is composed of your reactants and your products. The reactants are the substances or particles that enter and is changed in the chemical reaction. So mo ni siya ang imuhang kung sa ano pa sa kana production of products no sa market. Reactants are your raw materials. Mo ni siya ang imuhang gamiton para makaproduce ka og product. For example, you want to make a table, your raw materials kay syempre lansang, kahoy, martilyo, and all that, no? Those are called reactants in a chemical reaction. Now, we also have what we call the products. The products are the substances or particles that are formed. Therefore, sa kung example kaganina, ang table, mo na siya ang product. Ang imuhang raw materials or reactants, mao tong nails, wood, and other nga reactants. So, for example, here, this is a chemical reaction involved in photosynthesis. Now, this is the process in which plants can make their own food. Now, as what you can see here, oftentimes, always remember this nga, kana bitang na arrow din ha. Most of the time, ang nasa yung left side, no, of the arrow kay ang reactants. And kanang nasa right side, kanang gipadulungan sa imong arrowhead, muna siya ang imuhang gitawag nga products. So in this case, no, in this example, what are your reactants? Look closely. Unsa imong reactants? Your reactants are carbon dioxide and water. Whereas ang imong products kay unsa man? Your products are glucose and oxygen. That is correct. So, again, reactants, mo ni siya ang musulod sa reaction and gina-change. And then, lastly, ang product siya ang ma-form sa imuhang chemical reaction. Okay? These are your reactants and these are your products. Now, let's proceed with the factors that affect the rate of reaction. Again, rate of reactions mean the speed, no? Sa kapaspas. So, we have four main factors. First one is activation energy. Muna akong gidiscuss kaganina. Actually, na-discuss na gid nako. So, activation energy. When a collision provides energy equal or greater than the activation energy, chemical reaction takes place. That means that kung higher ang energy sa imuhang reaction, no? Kung higher ang kinetic energy is energy in motion. Kung mas paspas kibali ang movement or mas taas ang kinetic energy sa imuhang collisions, then the activation energy akong i-emphasize, then the chemical reaction would take place. If you're going to look at that one, in this illustration, no, this is your energy barrier. Murag katong wall akong gingon ganina. Now gusto nimo nga i-roll, no, imong i-roll ang imuhang bato. No, gusto ka nga mo ni imuhang reaction no mahitabo. Now, how are you going to do that? Of course, you need to surpass, no, the activation energy. You need to surpass this hill para mahitabo imong gusto nga mahulog ang bato sa pikas nga side. That is why you need energy, no, in the form of kinetic energy in order for the stone to surpass the hill or your activation energy, no? So that is why pag imuha na siyang malabuan ang imuhang activation energy, then a reaction will take place. Dara, nahulog na ang imuhang bato sa other side. Mo na siyang pasabot sa activation energy. Second, temperature. Always remember this rule. Increase in temperature, increase in rate of reaction. Syempre, nganong man? Here is the reason. Energy is applied to increase the temperature, right? Pag gina-increase nimo ang temperature, that means taas pa ang heat energy. And this increase in heat energy would increase the kinetic energy of your molecules. So the energy added provides additional kinetic energy to the reactant molecules. Muna kong gingunina. Therefore, higher kinetic energies means greater frequency of effective collisions. Siyempre, pag mas taas ang heat, mo taas man ang kinetic energy, mas paspas mag-move ang imong mga molecules. Therefore, mas daghan ang collisions, right? So, kung mas daghan ang collisions nga na ay proper orientation, then your chemical reaction would also increase. Example, mo ni siya ang molecule sa cold water, no? Hinay ang vibrations, hinay ang iyang movement, mo gani ice, maka-form ta og solid nga ice. Whereas kung hot water, as what you can see, no, paspas ang iyahang or mas energetic na siya kay init man. Aside from that is mas paspas ang movement sa imuhang molecules. That is why between the two, no, types of or phases of water, mas taas ang chemical reaction in hot water compared in cold water. That is also why mas dali tunawon ang mga substances, no, like salt or coffee or sugar in hot water than in cold water because mas taas ang kinetic energy sa imuhang ininit nga tubig kaysa sa imuhang bugnaw nga tubig. That's it. Third factor is concentration. Concentration, that doesn't mean ka na nag-concentrate ka nagtutok ka sa kabagay, nag-concentrate ka to. Concentration in science is different, no? Concentration is the amount of solute dissolved in a certain amount of solvent. That is concentration. So, pag daghan ang solute, tapos gamay lang ang solvent, concentrated ang tawag ana. However, kung gamay ang solute, tapos daghan kay ang solvent, that means ang tawag ana is diluted nga solution, no? Mo na siya ang kalahian sa duha. So, what is the trend or what is the rule? An increase in concentration increases the rate of reaction. Nganong man, ma'am? Nganong pag mas ispiso, ang tawag sa Bisaya sa concentrated is ispiso. Nganong kung mas ispiso, ang imuha ang isa ka solution, mas taas man ang rate of reaction. Here's the reason. Concentration is the number of molecules present in a specified volume. When the concentration is higher, syempre, more particular particles are present. Mas daghan ang imong molecules nga present. Therefore, there is a higher frequency of effective collisions. I will give you an example nga picture para mas dali. Tanawa ning isa ka solution nga diluted, katong labnaw, lasaw. Di ba gamay lang ang particles? So kung gamay lang ang particles, mas gamay ang possibility nga magbangga siya with another particle, right? So mas baba ang chemical reaction. Whereas kung mas concentrated ang imong solution, mas daghan ang present nga particles na possible na magbangga-bangga. Therefore, this increases the frequency of your effective collisions. Muna siya, between the two types of solution, mas taas ang possibility of a chemical reaction sa imong concentrated nga solution rather than your diluted or labnaw na solution. Okay, that's it. The last factor is surface area and particle size. Now, the smaller the particle, the faster the rate of reaction. Reason: smaller particles have larger surface area, and the greater the surface area, the more sites of collision there will be. Now, always remember this nga, kung gagmoy ang imong particle size, no, mas dako ang area nga free siya to what? To interact with another particle, no? I will give you an example by looking at this illustration. For example, this is your kaning particle, no, na gusto nimo i-react, no? And then mo ni siya ang nasa imong palibot. Okay, nga mga other particles. Tanawa ning buo siya, nakakumpul siya. Compare it with here nga kuan na siya, nakabulag-bulag na siya, no? Gagmay na siya, mura siyang nakagidugmok, no? Asa ang mas dali tunawon or asa ang mas dali nga mas daghan og kanang collisions ani, kaning tibugol siya nga buo or kaning gigagmay-gagmay na siya. Syempre, kaning gigagmay-gagmay na siya because ang imong smaller nga particle size, mas dako ang space, mas dako ang surface area nga maka-interact siya with another nga particle or molecule. Correct? That is the reason why kung atong siyang isipon in a very kanang practical way, asa man mas dali tunawon ang kanang buo nga asukal or katong asukal na nakadugmok. Siyempre, mas dali itong asukal na nadugmok, correct? Ika naman, mas dako ang area nga exposed siya sa water. That is why mas dali siya maka-interact with water. Compared atong kumpul siya nga sugar, which is buo. Mas gamay lang ang area nga maka-interact siya with water because buo man siya. Okay? So, always remember the 4 factors affecting the rate of reaction. Muna siya yung pasabot. So, I will, before I end this tutorial video or supplemental video, I will repeat, no, the 4 factors. First is activation energy. Again, if the kinetic energy will surpass or be greater than the activation energy, then the chemical reaction will take place. Second is temperature. The higher the temperature, the faster the rate of reaction. Third is the concentration. The higher the concentration, higher pud ang chemical reaction rate. And the last one is particle size. The smaller the particle size, the faster the chemical reaction rate. Always remember these 4 rules in analyzing a chemical reaction. So now you are going to proceed to your activities in the module. So please do answer them honestly and diligently, and I will see you on our next supplemental videos. Bye everyone, and thank you for listening.